So the topic which we are going to cover today is Maven. What is Maven? Maven is a build management tool which automates few of our processes which we have to do manually if we are not using any build management tool. There are many more tools available in market quite similar to Maven. Maven is the most famous one, but yeah, there are many which are getting famous and which are already famous. Like one of them is Ant. Ant was a tool which had the market for long, but now it's out of market. People have completely, or you can say most of the people have moved out of Ant. Second one is Maven, which we are going to learn. Then there are few more like Gradle is there. So they all these are build management tool. They automates many of our processes as well as uh, creating the artifacts or managing the reference libraries which a project has and so on. Okay, so the project which you see here, the modular framework, this project, if I open it, you can see that in the reference libraries we were using so many jar files. Okay, still there are very few, like there are only 12 or 13 jar files, but in a normal project when you'll actually start working with your frameworks, you might see that this list goes on and on. This is first thing. And second thing, let's say if you're working in a team of 3 or 4 people, then you might develop your code in, let's say, X version, and let's say your teammate is working on Y version. Then uh, then once you are merging the code, you might find difficulties because one of the person was developing the code in an older version and then other person is developing in a new version, and there might come a chance where some of the features might not work in the older version or might not work in the newer version, right? So to remove this discrepancy, what practices followed in real-time projects is, in real-time projects, everyone uses a common set of jar files. Okay, now how to get the common version? So for that, this Maven projects come into process. What it do is, it uh, there is a file in it. There is one XML file in it in which we mention what is the jar file required. Okay, and uh, Maven has a repository on its own. There is a big repository, and the path for that is just Maven repository. You just have to type Maven repository and you will get this. So probably if you recall, once we when we were covering Cucumber framework, in that we downloaded most of the jar files from here. All the Cucumber files we downloaded from here. Okay, so actually this is the Maven repository where it has a big repository in which um, it keeps all the jar files with it. Okay, actually it does not keeps the jar file. All the developers, or you can say, let's say if Selenium organization who is maintaining Selenium, they sends their code to Maven. All open source sends their code to Maven. Maven also has a private repository. It also has a public repository. So the tools or the jar files which we have used, they all are uh, they all are uh, uh, they all are, you can say, public repository because we are not paying anything for that. Okay, all the open source code is put in that. Okay, so now comes the question how to use Maven and what all other uses are there. So we'll learn all those things one by one. Okay, and there are a few questions which interviews ask a lot, so we'll cover that also. So Maven can be used along with the Eclipse, and it can also be used as command line tool. Okay, both options are available with us. So for using it command line, you have to first install Maven. Okay, so just on Google, just type Maven download. Okay, so when you do Maven download, it will take you to the first option only. I mean the first link. Go to that link, and here in the file section, the second option we have is Apache Maven 3.5.2 bin.zip. Download it and unzip it. Okay. Again, Maven is an open source tool which is provided by Apache organization and it's free to use. Now once you have downloaded it and unzipped it, so I have kept it in my libs folder. I also recommend you all to keep it either in C directory or in your libs folder. So in my libs folder, you can see the first link, first directory is Apache Maven. In this, I've kept all this. Okay. So once you have downloaded and unzipped it, next step will be to set the Maven path. Okay. So I'll set the Maven path. I hope you all know how to set the path now. We have done it many a times. So on this PC, right click properties, then advanced system settings. Then in the advanced, there is a section environment variables. Go to environment variables, and then in either in system variable or in user variables, add the Maven path. And how to add? Just click on new and type Maven underscore home, all in caps, and in the variables section, copy paste this path. Okay, till Maven Apache Maven 3.5.2. Paste this path, click on OK. I've already added, so I'll not add it again. I'll just show you. Yeah, here is my Maven path. Okay, then search for path, normal path, and edit it. And at the end, just like we added Java home, here also you have to add like this: percent Maven underscore home, then again a percentage backward slash bin. Click on OK and your Maven path will get set. Okay, to verify whether your Maven path is set properly or not, open the command prompt and here type mvn hyphen version. Okay, if it returns you something, that means your Maven path is set properly. But if you gives a if it gives a response that Maven unrecognized command, that means your Maven path is not set properly. Okay. Okay, so here you can see that the Apache Maven 3.5.2 is something which is installed, and it also gives the version, Java version it will be using. Okay, so once this is done, that means my command line Maven is done. Okay, earlier in the older versions of Eclipse, we had to install Maven also, but now Maven comes by default in Eclipse, so you don't have to do anything. Okay, it's already there. Now, and I hope everyone is using the latest version only. Something above, like mine is Luna. Sorry, not Luna. It's let me see which version I'm using. Yeah, it's Neon. So anything above Neon is having Maven inbuilt. Okay. Yes, Rupesh. Oxygen is the latest one, so that anyways have it. Okay, moving on, the next step will be to creating a project in it. So to create a project, right click here, click on new, and then go to others. And here search for Maven. You will get three options: uh, Maven project from SCM, Maven module, and Maven project. Okay, so select the last one, that is Maven project. First one will you will choose if your code is kept in some of the SCM tool. SCM tools are like Git, maybe Perforce, or any other tool, Git, GitHub, Bitbucket, and so on. Okay, if your code is kept there and it's a Maven project, then you have to use the first option. But here we are creating a local project, so I'll just select the third option, that is Maven project. Okay, select this, click on next. Poonam, your question in Luna. I guess in Luna also Maven is there. See if you are able to create a new project. If not, then I'll explain you how to install it. But if I recall properly, Luna also had a Maven by default. Okay, so you will get this second window. Here it's saying use default work location. It's checked, so you don't have to select the work location, let it be there, workspace location. And also check this first one, that is create a simple project. Select this. Okay, Click on next. It takes you to this window. Here you have to fill up some parameters, and in these parameters the first two are mandatory one: group ID and artifact ID. Group ID is like a group. Like if you're working in an organization and it has multiple projects, so your multiple projects can have a can have a similar group ID. So it's like you can say it's a bigger umbrella in which your multiple projects can lie. Okay, so here you can give any name. Let's say I'm giving a name, com.qa tech, uh, qa tech hub. This is some name I'm giving, or let me just name it qa tech hub only. And then in artifact will be the name of the project. Whatever project name you see here, cucumber project or edureka project or modular framework project, that name you have to give here. Okay, let's say I'm giving the name as learning Maven, and let me give today's date 21/01 2018. Okay, so this will be the name of the project. Here you can give any name, learning Maven, and description also I'll put same, learning Maven. Okay, parent project, like if this project is related to some other project, then you can give all other options here. Okay, and in the version will be like when you will create uh, some artifacts out of your project. Okay, like Selenium has its jar files, right? So those jar files are like artifacts, they are end result of your project, right? So when you'll create something like that, then this version will help you in versioning your uh, versioning your uh, artifacts. Okay, giving a number out of it. Like if you see Selenium has this version along with it, like these 3.8.1 or 3.53. So these are versions, so that is what comes here. Okay, and then click on finish. You will see it will create a project for us, learning Maven, and if we see properly, it has a little different symbol. The earlier projects which were created, they had a J, whereas this has an M. That means this is a Maven project. If you open it, you will see by default JRE system libraries is added. Okay, and it has an src folder as well, and it has these four folders: src main java, src main resources, src test java, and src test resources. Okay, so uh, unlike your java project, there this hierarchy is like this, and here it has some standard folders. The first folder which we have, this is to keep all our java code. Okay, and with respect to that java code, if you have any configuration file, any properties file to read, that you'll keep in resources folder. Okay, and if you have some test cases, then those test cases you'll keep in java folder, this third one, src test java. So this is specific to test, this is specific to your uh, java code, and this one is like resource files. Okay, any configuration file or any property file if you need. And if any property file or configuration file you need for test cases, then you will keep that in fourth folder. If you see here, this JRE system library, it is pointing to Java 5. Actually, what happens is there is a small issue with this Maven, that it automatically or by default always points to Java 5. But we are working on Java 8, so we need to do two steps to change. First step is remove this JRE system library. Internally, if you'll see, it is pointing to Java 8, but it is referring to 1.5. So inside this, you'll not be able to use features 6 and above. Okay, you will only be able to use features which are till Java 5. So the best way is remove this. How to remove? Right click, build path, and remove build path. Then in your project, right click, Then there will be an option of build path, configure build path. Earlier we were going to add external jar, but now we don't have to go to add external jar because we need to add some internal library. So I'll click on this add library, and here there are many options. Select the one, this one, JRE system library. Click next. It will show you all the JRE installed on your system, and it by default in my workspace, the JRE which is being used is this 1.8.0 underscore 121. Select this and click on finish. Click OK, and you will see here JDK 1.8.0 121 has started coming. Okay, you might face another challenge which I faced earlier, which I fixed it, and that challenge could be instead of JDK, you might be seeing JRE here. Okay, if that's the case that you are instead of JRE, you are seeing instead of JDK, you are seeing JRE here, then how to resolve it? On your project name, right click, and then there is an option of properties. Go to properties. In this properties, you will see a section Java compiler. Open it. uh, yeah, this Java compiler, open it, and here there is okay, this is second step. This everyone has to do, not only the people who are using uh, who are getting JDK, but JRE also, they also have to do both of like everyone has to do this step. Then there is a Java compiler, and by default the Java compiler selected as 1.5. Okay, so from drop down select 1.8 because we are using Java 1.8. If you have Java 9 on your system, then select Java 9 also. Click on apply, click on OK, and now your build is pointing to Java 8. Now your compiler is also the compiler which is being used is also Java 8. So these two steps are for everyone. And the third one, if you're seeing JRE instead of JDK here, then for that you have to go to Windows, go to Preferences, and here there will be an option of Java. Open this, and somewhere you will see compiler. Not compiler. Just give me a second. Yeah, this installed JRE. In the Java section, there is installed JRE, and here by default this JRE 1.8 this will be selected. Okay, if this is selected and other option is not there, then click on add, click on standard VM, click on next. Here, here in the JRE home, select the path of JDK. Okay, go to C, then Java, program files, then Java, and then there is a JDK library. Select this, click on OK. So by this will come, and then click on like I already have this on my system. The JRE name is already in use. I already have this on my system. Otherwise, I would get this section, this finish highlighted. Click on finish, and you will see the second option coming, and check on that, like select the JDK. So it's like a toggle button, you can select any one of the two. So just select this JDK and click on OK. Okay, so these are three mandatory steps. First step is that by default Maven is pointing to Java 5, so you need to change the JRE system libraries. First step. Second step, change the compiler in the properties for your project. Third step, in your Windows, go to preferences, and in Java section you will see this installed JRE. Select this one. Okay, and here also in the compiler we can see it is pointing to 1.1.8 because it is the default one. The other one we selected for Maven. Okay, so in Java you have to change uh, in the install JRE you have to change this. Click on OK, and you will see like for now you will not see anything, but if you'll not do any of these settings, you will start getting problems. And trust me, these issues are resolved like in 1 or 2 hours, and I'm just telling you straight away. Okay, so any questions till now? Anyone, any questions here? Okay, so moving on, next very important point in this Maven is this pom.xml. And this pom is different than the page object model which we studied. That was a design pattern, and this is project object model. Okay, it this is one file which gives us all the project related information. You can say this pom.xml is the master file of your Maven. Anything which executes from here. Okay, when I open this pom.xml, and if you see this in overview section, you will see all the information which we added while creating this Maven. Here you can see the group ID, artifact ID, the version, packaging, like whether you want it in a jar format or a WAR format or any other format. So I'll say I want it in jar format, name of the project, okay, description, and so on. Other information we have not added, so we'll see what all are required. And in this section, at the end, there is pom.xml. Click on it, you will get that same information which is there in this menu section here. Here you will see it in XML file. So you can see model version, group ID, artifact ID, version, name, and description. Okay, so this is first thing. And next, what you have to do in it is you can uh, let me quickly open one file because there is a just give me a second. There are lots of files which I'll be needing, so I just opened one of the file. Okay, now in Maven, whatever you do, like whatever information you provide, okay, that are provided in plugin format. Okay, Maven provides us lots of plugins which can be used um, for your project, in your project. Okay, couple of them I'll be mentioning here, and those plugins we generally add in build section. So there is this build. Inside this build we add. Inside build we can add plugins. Inside plugins we can add plugin one by one. Okay, so the first plugin which we need is this one, org.apache.maven.plugins. This is the group ID, and the name of your, or you can say the artifact is Maven compiler plugin. Okay, what does this means? This gives one information to your Maven that I'll be using this particular version and source and target of my Java will be 1.8. So in case you're not using Eclipse, okay, if in case you're not using Eclipse, then from this information, from this plugin, your Maven will get to know which compiler to use. So I'll just copy this plugin and put it inside here. Okay, so I have added one compiler, Maven compiler uh, plugin, which is the version is 3.5.1 and source is 1.8 and target is 1.8. So this is first step, adding this compiler. Okay, next compiler will like whatever next compiler we have, I'll discuss about it later. So this is my first compiler, and just save your file. When you save your file, you will see it is building a project. Actually, it is setting up all the parameters which you have added here, the new parameters. Okay, currently like nothing was something which this plugin makes visible, so nothing happens. But I'll show you in next step that what happens when your project is built. Okay, so any questions till now? Okay, next is there is something known as dependencies. Okay, in this pom.xml is also used to maintain the dependencies. Now, what are dependencies? As I told you, in modular framework, we are using so many reference libraries or third-party jar files. All these jar files, all these jar files which you see here, these are we were adding them manually by downloading from their respective path. But you don't have to do any of these things if you're using POM. Okay, or you're using Maven. What you have to do is in your dependency section, you have to mention the dependency and your Maven will automatically download it from Maven repository. Okay, like which all jar files we will be using. The first jar file which we'll be using will be Selenium jar file, right? So this is the dependency for Selenium jar file. Okay, and from where I got this, you don't have to do anything. Just go Google and see Selenium Maven dependency. Search this. When you search this, it will automatically give you the results this file. So here you can see the dependency is org.seleniumhq.this. This is the name of the group ID and the artifact ID is selenium-java and 3.7.1. To work with Selenium, we just need this artifact. If you have to use grid, then you need to add selenium-server as well. So copy this dependency and paste it here and change the version. And I know the latest version is 3.8.0 in the market. So I'll just list out this. Copy this and paste it in your dependency section. When you add this in the dependency section and press Ctrl S, you will see again building workspace. It is building the workspace and it will take some time. What it was doing, actually it was downloading all the jar files. And here you will see another folder is added here with the name Maven dependencies. If you open it, you will see all the Selenium jars are there. Okay, and it does not download the jar files like Selenium. It does not download jar files the way we got in. Like it does not download a single jar file, that is Selenium standalone jar file. It downloads all the internal jar files which you will get from here, like seleniumhq.org. If you'll go here in the download section, here when you download this, whatever jar files you'll get from here, that is the one which it has added, and it is automatically included in our project. Now later on, if let's say new version is coming, then you just have to come here, change the version, and it will automatically remove the older jar files and introduce the newer one. Okay, so this is the first step. Any questions till now? Okay, Rupesh, you have a question. What is source and target? This is the Java version you're using. Okay, Java version for source and target means when you are compiling, then what to use, and when you are after compiling, when you're creating the artifacts, what to use. Okay, so this is Java version. 1.8 is the Java version. If you're using Java 9, put 1.9. If you're using 7, put 1.7. Okay, so is the dependency section clear to all? Any questions? Okay, like this, all the other uh, whatever I need, I'll just keep adding. Like the first one I need is log4j for my project, for my framework. So I can add log4j here. And then I also need testng. So I'll just copy this testng, paste it here. Okay, and then we also need POI Apache. So for POI Apache, we need two dependency to be added. One is POI and second is POI-XML. So copy and add them here. Okay, once all your dependencies are added, press Ctrl S again. Here you can see it is building the jar files, and here you will see many more jar files are being added. So once your compilation or the building of this project will be done, you will see here all the jar files which are which I mentioned or which we need are downloaded and are included in your project. Clear? Any questions, anyone? Okay. Then next step will be putting the values in these folders. Okay, putting the jar files in these folders. So as I told you, the first folder, this Java, it contains all the Java code. Second, it contains any configuration file if you have. Third, it contains the test cases, and fourth, it contains again the configuration files if we have. So what I'll do in my uh, like in the frameworks which we created earlier, okay, like in your project, in your class, whatever framework I copied, I've converted them into Maven. Like whatever changes were required in the Maven, I did all those things and I created that. Okay, so nothing new I added, just changed if some path is changes required or is some import file changes are required. I just did that and I have prepared the complete code for you in Maven form. Okay, so here in you can see in com, I've created one folder QA in which I'm putting all the Selenium related stuff, and I have created one folder Mercury Travel, one folder with this name, and inside this I've kept all the pages. Okay, so in QA we will have on all the contracts and its implementation. The things which were changed, which I was just mentioning, was this these packages. Like earlier they were commonlibs.implementation, now they are com.qa.commonlibs.implementation, and if something else was required to be changed, I did that. Okay, so all the contracts as well as all the implementations are changed here to fit into this project. Similarly, we added Mercury travels, flight, holiday, all these sections in Java. So these are related to Java. So everything I added here. Now, if any configuration file is required, that you need to add in this source. Okay. So whatever config files we have or anything we have, we need to add all of them here. Then in this src test Java, here what all we need. So here we need all the test cases related things. So that also I have covered up. So in the test, I'll go to this and we'll copy all this and we'll put it inside here. So here I have created com.testng, this name, and here you can see base scenarios, demo common labs, and other information are there. Okay, Mercury travel homepage and so on. So all these information we added here. Okay, and I'm sorry. So one XML file I've created with the name common demo common labs. I'll just show you that everything is working fine. Okay, and the modular framework which I was using. Okay, so all other things like log files, like output, taking screenshot, then library folder, not labs, input folder, config folder, all these things which were my configuration files, I'll copy them in my resource folder. Okay, so let it get copied. It will take some time. So this way, your complete project is now converted into Maven. Okay, once I'll complete this, everything will be converted into your Maven projects. Okay, so here you can see config input output logs screenshot. What else will be required here? Only few path changes will be required, which you can do yourself. Okay, so I'll just show you that everything is working fine. So for that, I just created this demo commonlibs.xml file in which I'm running one in the test ng. I've created one demo common libs. Where is demo common libs? Here is the demo common libs. I created this file in which I'm just invoking a browser, opening QA Tech Hub, printing the title and closing the browser just to show everything is working fine. Okay, and here I'll right click on this project, run as test ng test. So you can see execution is happening. That means it has taken all the dependencies, all the Selenium related stuff, and there is no error or anything. So that means everything is working fine here. Okay, you just need to configure the paths and all. Okay, so this is one thing. Now you can also execute your code through this demo commonlibs.xml file. Again, it will be right click, run as test ng suite, so you can run it through this, which we have seen many a times. Okay, next is you can also run your code through this pom.xml. As I told you, this or Maven is one thing. It is used for maintaining all the repositories or all the library files. Second thing, it is also used to automate all the processes. Okay, so you can even execute your sorry you can even automate your execution also. So how to do that? In this, in the build section, there is one more plugin which we can add, and that name of that plugin is Maven Surface plugin. This plugin is used to execute testng file through Maven. So I'll copy this and paste it here, and here you just need to mention the path of your XML file in this variable, that is suite XML files. The name of the variable will be suite XML file, and this will be the variable name. Okay, if I come here in the overview section, in the properties, okay, there is no properties. Okay, that will not come here. Okay, fine. So the artifact ID is this, version available is 2.19.1. There might be a latest version which can come. That would be most probably 2.20. Okay, when you add this and save this file, again it is building the workspace, and this plugin is added. Okay, so if the version or anything will be wrong, it will give you an error. Okay, then you just have to fix that error and proceed. Now to execute your code through this pom.xml, right click on this, go to run as, and these are the commands which you can execute. Okay, currently when as we are using Eclipse, so you can see that everything your Eclipse was automatically building a code, but in real-time projects, we don't automatically compile the code through Eclipse. We do it through Maven. Okay, so here there are many options like building, cleaning, and this test. So first is this clean. What does this clean do? It removes all the uh, all all the previous execution information. Okay, that way you can make your code as good as new. Okay, and in this learn Maven this, there is a folder which is created with the name target. So if you'll go to this folder, okay, currently there is no target because that is empty. So yeah, you will not see anything, but yeah, you can see that it has deleted this folder with the name target. That means it has cleaned up everything through this. Now, next step, what I'll do to execute only the code, what you can do is, sorry, to execute your test cases, what you can do is right click, run as, there is an option Maven test. Okay, select, select that. What it will do, it will scan your projects, go to this, read this pom.xml file. It will consider all the plugins and whatever is mentioned. Okay, and then will execute the XML file which you have mentioned in the Surefire plugin. Okay, so it will do many things here. Okay. For the first time, it always takes some time, and then later on, it will be very quick. So you can see it is executing the test suite, and it has started the execution as well. Now it is going to queue up, close the browser, and you can see total test runs were 1, failure 0, error 0, and skipped 0, like whatever we executed. Okay, and if you'll come to this Maven project here, okay, the other folder. Here you can see one folder with name target is created. If you open this, this target has all the class files. Okay, so this is like artifacts. This folder has artifacts. Artifacts means all the code in compiled form. So your Maven first compiled the complete code, and then here you can see there is okay, these are an empty because yeah, Surface reports. This is what I want to show you. So Surefire reports, just open this and you will see the complete the test output folder which TestNG used to create. Now the reports are coming in here. Okay, so in the advanced section of Maven, you can also learn how to send these reports to through email. That comes under advanced part of Maven, but you can see that the TestNG reports are coming here now. Okay, and it is the same report. So you can see the report. Clear? So this execution can be done through this, and not only this. I mean, we see two commands. One was Maven clean, and second we saw Maven test. There is one more which you can do, that is right click, run as. There is one Maven install. So when you do Maven install, what it do is let it get execute. So again it will create the artifact, it will execute all the test cases whatever you have. Okay, and it will do one more thing which I'll show you. Let it get execute. In this folder, in the target folder, you will see this this one jar file which is created. Okay, so this jar file is, see, look at it, what it is there. Name of the project hyphen the version number dot jar. So it has created a jar file out of this, out of these product, these artifacts. It has created a jar file. So in your real-time projects, when you have to deliver your code to uh, when you have to deliver your code to some third-party people, then generally we create jar files using Maven. Okay, so this is the exact way these like the Selenium jar file which we have. So they are also using Maven to create their artifacts. Okay, so this is how Maven is used in projects. Now, any questions till now? Just one more thing, you can, the commands which I executed through Eclipse, you can execute them through Maven command line also. So just go to this path where your pom.xml is kept and open the command prompt. Okay, so actually what happens when I do like this, when you are in this workspace inside this, and here in the bar, taskbar, if you open command cmd, if you type cmd and press enter, you will see you are automatically switched to this path. Okay, if you will not do this way, if you will not write the cmd in this path, then the whatever command prompt you will open, then you have to do a change directory cd and then the path. So that's why I just did this way. It automatically takes me to this path, and here just type maven first command. Let's say I'm writing maven clean. What this maven clean will do, it will clean up the project, the directory for us, and you can see that the folder which we were looking, that target folder is removed. Okay, now come here and say maven test. So this command is to execute the test cases. So it will compile your code and then will execute your code and then execute your test cases. So you can see it has started executing. Okay. So, so all other commands also like Maven. So always remember to clean before starting any new thing, so that your target folder is empty. So now you can also do Maven install from here. So the same steps which we did earlier, it will do. It will create a jar file out of it. The only thing is now we are running it through command prompt. Okay, so this is all about Maven. And this much is more than enough for your interviews and for using it in your real-time projects. The only thing will be the most important thing you need to know about is this pom.xml. So in pom.xml you need to mention the dependencies which you have. So in the dependency section you will see which all dependencies we have added. Okay, so we have added Selenium Java, Log4j, TestNG, POI, and POI XML. If you have anything new, you can add it here. Okay, or you can go to pom.xml, copy it from Google, and add in the dependency section. Just Control S your file; it will automatically download from internet from its Maven repository. Clear? Any questions now? Okay, so this is all about Maven. Now you can practice it and convert your complete framework into Maven. And if you face any challenge, do let me know. I'll help you. Okay. So next is let's start with the DevOps. I wanted to cover a few things in DevOps. Let's start with that. Okay, I'll cover a few of the topics here, and then we will also see Jenkins because a couple of people here have not covered Jenkins in the framework. So I'll be covering frameworks, sorry, Jenkins, and yeah, then we'll see what else we can cover. So let me start with what is DevOps. Okay, so here you can see when I'm talking about this DevOps, I have highlighted the capital D and capital O. That means this is not one word, it is an abbreviation or a combination of two words. So dev and ops. Dev means development team and ops means operations team. So can I say this DevOps is developers and operations team working together? Okay. Uh, so yes, this is one of the definition of DevOps. There is there is a joke you can say that if 10 people sit together, everyone will give a different definition of DevOps. Okay, so if I like what people say about DevOps, let's see. So some people say that DevOps is a collaboration between development operations team. That means the thing which I just showed you here, that means developers and operations working together. So people say that it's a collaboration where development team and operation teams work together. Some people says DevOps is using automation as much as possible for every task. Some people says DevOps means treating your code as infrastructure. Some says that feature switching, feature toggling is something which is DevOps. Some says DevOps is small deployment. So what is actually this DevOps? DevOps is all of these things. All these bits and pieces which you see here, which is mentioned here, are true about DevOps. Okay. If we move on to one of the definition for our understanding, DevOps is the union of people, processes, and products to enable continuous delivery of value to end user. What does this statement means? This means that DevOps is not only about people, it's not only about processes, it's not only about early delivery to the market, it's a combination or a union of all these things. Okay, it's the people who make DevOps, it's the processes who makes DevOps, it is the tools which we use to achieve all these is DevOps. Okay, so people, remember this, people, processes, and the tools which we use to deliver the product or the value to the end user is DevOps. The combination is a DevOps. Okay, so DevOps encompasses these four features. First one is culture. Culture to emphasize on going to market rapidly. That means as soon as your code is developed and is ready to use, send it to the market. Send it for validation. So this culture of comes within inside. Okay, it's something not uh, which can be developed in just one day. It is something which comes with time. Okay, so you can say DevOps is more than people, processes, and tools. It's about culture, and this culture grows within the organization. It can change the organization. Okay, second is measurement. Measurement of what you are delivering, measurement of culture, where we are going in, understanding what we are actually doing. Uh, this is what mes- this is our second, you can say, feature of DevOps. Third, very important, is automation. Automation of each and every task. Not only automation of your test cases, but automation of the way your code is built, the way it is deployed to the production, to the test environment, all the version controlling, all the test cases, everything. Automation of everything is something which is a key feature in DevOps. And then last is collaboration. Collaboration of everyone, collaboration of people and processes, collaboration of development team, operation teams, all the people working together is one of the key feature of DevOps. Okay. So any questions till now? Okay. So the next is the holistic view. Like if I talk about the holistic view or the overall view, how a DevOps look like, so that can be divided into four sections. First one is development, where developers do all the requirement gathering, they develop the code, then they do all the versional controlling, they do their test management, they do their bug tracking. So all these things come under development section. Then we have testing, doing testing at each and every level, like doing testing at unit tests, writing unit tests, then integration testing, load testing, automation, security, UI testing, performance testing. So all these things are part of DevOps culture. Then deployment of the code. Deployment of the code includes environment definition, configuration, and provisioning. So everything related to the infrastructure. Okay, let's say you are using AWS, that is Amazon Web Services, to deploy the code, or Azure services to deploy the code. So what kind of environment you need, what are the configuration you need, what is the provisioning you need, and all those in infrastructure related things should also be automated. Next is application configuration and deployment. So these are the configurations which are at your application level. Okay, what configuration makes a particular feature enable or disable? What configurations required to run it on Azure or to run it on Amazon, and so on. Next is approval workflows and automation. So as uh, you can see that we are putting more emphasis on automation. Okay, and you can say this DevOps or Agile was the one of the reason of Selenium becoming famous. so much demand in market of Selenium is because of these DevOps culture. Because here more and more emphasis on is on automation. And as I said earlier, not the only automation of Selenium, but automation of everything. Okay. Now, the last is monitoring. So once your code is deployed and everything is there on production, then you need to monitor the application performance. If some alerts or notifications are coming, you need to uh, take them seriously, cover them properly, and then deploy it to the again deploy it to the market. Okay, say for example, if some defect is coming, you just need to quickly take it, fix it, and send it back. So that's what comes under monitoring section. Then whatever we studied till now, if I have to combine everything into one single definition, you can say that you cannot buy DevOps and install it. DevOps is not a tool. Okay, if people says Jenkins is a DevOps, no, Jenkins is not a DevOps. Jenkins is a way to automate the processes of whatever you need. Okay, so Jenkins is not a DevOps. Jenkins is a tool. Okay, DevOps is not just automation or infrastructure as a code. DevOps is people following a process enabled by products to deliver value to end user. Okay, so this is, you can say, the definition of DevOps. So in a nutshell, if I say it's not just processes or it's not just product or not just tool, it's people, processes, tools all together working together to achieve one goal, and the goal is to deliver value in small increments. Okay, so if any one of you is working in agile, you might have seen now your product is delivered to the market or delivered to the production in very short span. Earlier when we were in waterfall model, then after maybe a quarter or maybe after 6 months we used to make our product live. But that's not the case in agile or in DevOps. Here we deliver the product as soon as it is ready. There is something known as hypothesis uh, delivery. Okay, so what is that hypothesis driven development? We'll learn about that in some time, but that is something which has made the delivery as early as possible to the market. Okay, so again, let's revise the definition we started in the start. DevOps is the union of people, process, and product to enable continuous delivery of value to our end user. So remember this definition. If somebody asks you in an interview what is DevOps, so you can just mention this. And if I talk about the key practices in DevOps, so these are the key practices, and not everywhere you can lie, but yeah, an organization which is following DevOps must follow as many processes as possible. First one is configuration management. What does this configuration management means? Configuration management is understanding what we are deploying, how we are deploying, and what is the configuration of what is going to be in production. So whatever you are deploying on production, what are the different configuration for that? Okay, what are the configuration at application level? What are the configuration at infrastructure level? That is very important. Second is release management. Release management is how we are building a release pipeline that we can trust. That means the process which you're creating to make your product from your environment, from your development environment to production, the process should be smooth. It should be trustable. Okay, and how that can be made trustable, we'll learn in some time. Then second thing comes continuous integration and continuous deployment. Okay, so these are the two things I want to discuss in detail. So for that, I've written an article long back. So let me just open that. Yeah. So let's talk about these three terms: continuous delivery, integration, and deployment. Okay, so actually it should be continuous integration, delivery, and then deployment. So these, I mean, integration and delivery should be interchanged, because first comes integration and then comes delivery. Okay, so what is this first step? That is, what is this continuous integration? In continuous integration, you have an application that on every code commit, whenever your developer commits any code, a build is created automatically. Then unit test cases are run and application is deployed in the test-like environment. So this comes under continuous integration. Continuous integration is as soon as your developer has committed any code, that code goes into your repository. Okay, it triggers an event, and using some tool, that tool can be any tool, does not matter. It can be Jenkins, it can be team source, it can be Bamboo, any XYZ tool. But what it will do, it will take your code and compile it and create artifacts out of it. And before creating artifacts, it will also run unit test cases on that code. Okay, so that comes under continuous integration. So very first step is continuous integration. So as soon as your code is committed, it builds the code, it runs the unit test, it also do this code metrics. Code metrics is to checking some of the metrics, like how much code coverage you are giving, how much test coverage you are giving, then what are the other related other code metrics in it. Okay, is there code smells? So something known as sonar is one tool which can be used here uh, to check the code smells. Code smells are some uh, known uh, you can say a bad way of writing codes. Okay, so some known facts of bad writing code. Okay, so your sonar scans your complete code and sees if something is not a standard way of writing code, it counts it as a code smell, which does not affect your code at that particular moment, but going forward can make your code or the complexity of code high. So for that we do this code matrix. Then versioning. Versioning means every time you create or execute the build, it should give you a different version number. Okay, why different version number is required? Because let's say if something is working on one code, one set of code, but it fails to work in the second set. So you should have a version associated with it, so that later on you can know that okay, in my build number 14 things were not working fine, in build 15 everything is working fine. Or if let's say a newer build come, let's say build 16 comes, which is not working, and you know want to go back, then you should know to which number you have to go back. So that comes under versioning. Then update symbol servers, this I'm not sure what exactly it is, but yeah. So these are some of the steps we follow in CI, that is continuous integration. And here I've also mentioned some of the tools can be used. Okay, like for build, uh, you can use Gradle, you can use Maven. Okay, for unit test you can use JUnit, you can use testng. For code repositories we have Yum, we have Git is there, RPM is there. So these are code repository. Then for code matrix we have Sonar. Sonar is one tool. Here is the Sonar Cube is the name. So here is the Sonar Cube. Okay, and so on. So these are the tools which can be used at CI level. Any questions till now? Okay, then comes the next one, that is continuous delivery. Okay, so what is this continuous delivery? Continuous delivery is to do automation and integration test on every build to catch early issues in the build. Okay, so continuous delivery is as soon as your code is compiled, is available, artifacts is created out of it, that those artifacts you'll send to the environments, test like environments or your test environments, where you will do a different level of testing. Okay, your testing can be your functional automation tests, running all the integration tests, and so on. So that comes under continuous delivery. Then next we have is continuous deployment. Continuous deployment is one step ahead of continuous delivery, where once your automation suite is stable enough that you can trust on it, it's reliable, you have a maximum coverage of your scenarios, then what you can do is you can move your code directly to production, to your live environments. That is what continuous deployment is. Okay, so moving your code to production like environment comes under continuous deployment. So this is a process you can see which I've mentioned. First one was committing a code and building a code and then getting artifacts out of it. That comes under CI. After that, this process till this staging is continuous delivery, and then after this, deploying into the production is continuous deployment. At each level you can do a different type of testing, like you can do functional automation testing, exploratory testing, user acceptance testing, some staging and pre-production, so running sanity suits on that. Okay, so and then once you are sure that everything whatever you testing you have covered, that's 100% proof of saying that your testing was proper, then you can deploy a code to production. And where like this complete process which we are mentioning here, this complete process is an automated process. Okay, nowhere you are doing any manual intervention. Clear? Any questions, anyone? Okay, so some of the practices which you can follow. uh, okay, so one of the key reason for using this type of implementation process is that it reduces the time it takes to deliver the product in the market. In 2016 survey report, it was found that a high-performance software development company deploys the application on demand basis as compared to the old process, which took days or weeks to deploy the application, which improves mean time to recover. Okay, how this mean time to recover is like what is the direct relation here? So if you recall when you were working in waterfall model and if some defect was coming, that defect used to go undergo a big uh, cycle before getting to the production. First, it used to come to the testers. They used to reproduce the bug, and then it was like a long process was there to identify when this defect is produced or reproduced or was committed. Okay, when this defect actually came in the market. So I remember that we used to test it on 10 older builds to just know where exactly this particular defect was introduced, and then a retrospective was done, why it was introduced, why it was missed, and then it was sent to the developers with exact way of or exact steps of reproducing it. Then developers used to check when this was introduced and what exact was the reason, and then a fix was provided to it, and then we used to send it back to the production. So a long process was there. So it used to take days or weeks to actually deploy back to the production. But now it's like on every commit your code is going to the production. Okay, that means as soon as your code is committed and it is going to the production, you know that I have deployed a very small code. Changes are done at very small area of code. If some defects come, I can quickly fix it. Okay, so that is how it has improved the mean time to recover. Okay. Another reason of using continuous integration, delivery, and deployment are that it increases quality as as inspection happens quickly instead of doing it the end. Okay. Just now I mentioned that as soon as your code will be deployed, you will get to know what exactly went wrong. And if your automation is strong enough, is reliable, is trustable, then even you don't have to wait to the production. Here only it will be caught. Your staging and pre-production environment which we have, that's an exact replica of your production. Okay, so the goal of continuous integration is that software is in working state all the time. So this is one of the saying by a person known as Jace Humble. Okay, now some of the practices to follow for continuous integration. So remember this. First one is the build should be executed in less time, less than 5 minutes. This is just a time, not every build is executed within 5 time. It depends on your application as well. Okay, but yeah, these days a concept of microservices is coming in market. So uh, by the time this microservices are coming, they have actually divided your code into small services, and the code size of those services are very less, so you can say that code can be compiled within 5 minutes or less than that. Okay, then commit small code. The little amount of code is easy to debug and inspect. As I told you that if you're delivering a large code, then it's very difficult to find where exactly the problem lies. But if you're committing a code very small, like small chunks, if you're committing, then it's very easy to debug and inspect. Don't leave the build broken. So if something has failed, something is not working, don't keep it like that. Fix it. Okay, next is use trunk based or branch based development process. So this is for your developers basically. We cannot do much in it. Yeah, if you can just ask your developers to use this way of developing code of branching. Don't allow faulty tests. Faulty tests are those tests which fails sometimes, not always. If they are failing sometimes also, then also there might be some reason for that. Find that reason and fix it. Okay, uh, don't let your code lie which has these faulty tests which fails sometimes and passes sometimes. Don't let them hamper. Next is practices to follow for continuous delivery. So this is continuous integration which lies here. So you need to follow these some of the practices. Okay, and as I told you, it's about culture, it's not about tools. So if you are following these processes, then only your tool will be helpful. If you're just using Jenkins and saying you're following DevOps, that's not correct. If you're following these practices, then only you can say you are actually doing DevOps. Next is practices to follow for continuous delivery. So what was continuous delivery? Continuous delivery was uh, doing automation as much as possible, testing your code at different level, like doing performance testing, doing functional automation testing, doing integration testing, doing regression testing, doing UI testing, doing security testing, and so on. So all these things which I just mentioned, if you're following those practices, that means that comes under continuous delivery. Some of the practices are only build artifact once. Okay, artifacts should be immutable. That means they should not be changed. Like if you have deployed one artifacts or one of your piece of your code in first environment, then in second environment it should be exactly same. No changes should be done. Otherwise you'll not be able to uh, find out the exact reason. Okay, so whatever artifacts you're getting in the first step, all those should go in the consecutive um, processes. Deployment should go to production line like environment before deploying to production to do acceptance testing. Okay, so the last environment which I showed you, this is most of the time this is exact replica of your production. Okay, it has everything similar, all the configuration, everything, data version, database version, build version, OS version, so that if something is being produced here, some defect is coming on this, it should be replicable here. Otherwise, most of time what happens is the live environments or the production environments which we have, some defects come there but are not reproducible on test like environment. So always one environment is kept which is exact replica of your production, so that if some defect is coming here, that can be easily reproducible here. Okay, so this is one of the practice you should follow. Then deployment should go to production like environment before okay, this is already done. Stop deployment if a step fails. If in this process any step is failing, stop the deployment then and there only. Don't say, okay, out of 10 test cases, 8 are passed, let me proceed. No, that should not be a case. Okay, even if your one single test case is failing, fix it and then only deploy it. Okay, next is deployment should be idempotent, that is, redeploying should leave your system in the same way as before. So if let's say something failed in between, then you should have a mechanism to quickly redeploy the older version of code as soon as possible. So that is what this statement means. Okay, so this comes under continuous delivery. And if I talk about what are the type of testing which can be done, unit tests, code hygiene, integration tests, TDD. TDD is test driven development, performance testing, security testing. So these are some of types of testing which you can do. Okay, then what are the different tools used at various stages of CD? That is continuous deployment. So these are some of the tools I mentioned. Like for version control, you can use some versioning control tool. Okay, Jenkins can also do the same thing for you. CD pipeline tool, again Jenkins, Go CD, Bamboo. These are some of the tools which you can use. Okay, build tools. So to create the artifacts which I just showed you also today, Maven can be used. Uh, Maven is famous with Java, so you can use this Maven tool with Jenkins. You can use TFS if you're working on .NET or C Sharp, and every every language has one or more tools to do this build management. Like your mobile, sorry, this Java we have Maven. We also have Gradle. Android mostly works with Gradle. Okay, then for unit testing, we have tools like JUnit, TestNG, NUnit for C Sharp, and so on. For integration testing, we have many tools like Selenium, Cucumber, Robot Framework, and so on. For performance testing, we have JMeter, Apache Test. Then there are tools which are there for security testing, and so on. Okay, so these are certain things which you should know about continuous integration, delivery, and deployment. So any questions till now? Okay. So this last two was infrastructure as code we have discussed. Then test automation. So all these five things we just discussed. Okay, test automation, application performance, and monitoring. Okay, so these were some of the key practices which in DevOps you should follow, and then some of the habits which can help you and your organization to grow in DevOps are these. First is team autonomy and enterprise alignment. That means let your team the flexibility to do the work they want. Okay, so let them do innovation. Let them write the code they want, following the practices and all. And your enterprise should be aligned with it. They should know uh, basically your enterprise or your organization should know what they are doing. Okay, next is rigorous management of technical debts. Now, what is technical debt? Technical debt is the uh, non limitation of the code which you have put it in your production in your code. Okay, so the Java code or any code you are writing, sometimes what happens is we write a code in a very bad way. Okay, that is not the standard way of writing code. We just write. We're using some iterations, some looping mechanism which takes lot of time. or we are writing some logic which is not an efficient logic. Okay, then those things adds to the technical debt. Okay, so if you are like if you are continuously increasing the technical debt, then that can cause problem to you only in the later stages. Okay, so rigorously manage your technical debt, sit with your senior members or architects to see this piece of code I'm not finding it useful, how I can refactor it, and so on. Next is focus on flow of customer value. So not only this is not only the job of your product owner or your stakeholders to deliver value to the customer, it should be by all. Your developers should start thinking in a way that whatever I'm developing, uh, whether it will give any value to the customer or not, because they are the first person who know how it will be used. Okay, so you should focus a lot on customer value. Next is hypothesis driven development. This is something which is becoming famous is become very famous in market these days. That is hypothesis driven development. That means before you deploy any code, before you develop any code, you should not wait for all the features to get complete. As soon as your idea has a shape, as soon as whatever you're developing is workable, deploy it and let your customer know whether they want that or not. Okay, so there is a term known as MVP. MVP stands for minimum viable product. As soon as, let's say, you're developing some product, maybe you're developing a product like you can fill timesheet. Okay, so a timesheet can have hundred of feature. Okay, right. It can have a feature like as soon as you apply leave in your time management, it should be sync with your Outlook. Okay, but is it so important for the customer? Before you deliver all the features in a project in a product, verify your idea by just creating a small bunch of features and sending them to customer and seeing whether they actually want that or not. One of the best example I can give you is, take the example of Redbus. Redbus, you can see now it's a very big website in India, okay, which has all the features like you can book uh, all the buses. It works in almost all the cities of India, and so on. Okay, so Jishan, you can just have a look on this redbus.com. It was a website developed in India where you can let me show you. So this is the website where you can book buses, hotels. You can hire buses for pilgrims and so on. So it has you can take some packages also now. Okay, but earlier the time when it was launched, when the time this Redbus was launched, it never had these many features. And the person who developed Redbus, he was not sure whether the idea which I'm thinking of will actually work or not. Because many a times that you feel that whatever idea I have, it's a very good idea. Okay, that can be a very good idea, that can be a very innovative idea, but do people actually need that in market? If you are developing something which is way beyond the time, if you are developing something which fascinates everyone, but like this time is not the correct time, then how can you validate that? You can validate that by deploying or by just creating an MVP, that is minimum viable product. A minimum viable product has only those features which are very essential. Like the day this Redbus started, they just had the list of all the buses which will be running from a city and at what time. that was their MVP. That was the first thing they did. They just had one single page on which all the buses name with their number and with the time when they'll uh, go from one city to other city was there. Then they added next functionality where you by calling the red bus guy you can book the tickets. And then when they started getting customer, they got to know that their idea has some value. Okay, they are delivering some value to the customer. So that time they started this online booking and all, and you can say still they are developing new things every day and deploying. Now they are just adding values to the feature, to the product. They are adding features. Okay, so hypothesis driven development, what does that means? It means that start or send your product as early as possible. Okay, see if your idea is something which is required in the market or not. If yes, then you can make it uh, uh, work on it. Okay, next is evidence gathering in production. Okay, one more thing comes in this hypothesis is you can take feedback from the customer. Maybe you're developing a code in such a way that you think you are developing features which you think is the best way, but your customer has different perspective. So take feedback from them. Okay, take ask them what they want. If that is something which lots of people, let's say hundreds of people are saying that X feature should be there in your product. So what is the sense of developing Y feature which nobody wants? It's better to it's better to invest on X feature. And this flexibility you can get only when you're going early to the market and you have a small stage of development. Like if you are working on waterfall model, then to make X feature, again you might require 6 months, and by those 6 months it might happen that feature become obsolete. Nobody needs that anymore. Okay, so it's always important to go to the market as early as possible. Then next is evidence gathering in production. Like uh, whatever is working on production, you should have way to uh, get what is happening there. Like some kind of logging feature is there, some kind of event management should be there. So you should know what exactly is happening on production. If something fails, you should quickly be able to get the reason behind that. Okay, next is life site culture. So this is again one of the habit which needs to be developed within the organization. That is, everyone like whosoever is working, they should have this habit of deploying or going live as early as possible. Okay, they should not wait for multiple features to come and then going to live. As soon as one of the feature is there, deploy it to the code. So this is one of the habit. We have talked about it a lot. Then the last is manage infrastructure as a flexible resource. Okay, I'll give you an example of this last. Uh, See, you should use an infrastructure which should be flexible. You can be able to increase or decrease its capacity in just clicks of seconds. Just a click, fractions of second, and your code and your environment should be maybe. I'll give you an example. Uh, you can see, just consider an example of iPhone. They generally launch their product in September. Before September, the traffic on their website is, you can say, is very low. Okay, because not everyone buys iPhone daily. There might be people who are buying, but that can be like 100, 200, or maybe 1,000 person a day buying iPhone on a day, on a particular day in one country, say in India. Now, uh, just think of the time when it's September and they launch their new project, the new product. Let's say next year on September they They are launching iPhone 11. Okay, now they have launched X. Now they are launching XI 11. Now you can see that the day it is launched, will the traffic will be same as the normal day? No, their traffic will shoot up X times. So when this is happening, do they need something extra? Yes, they need extra infrastructure. So how can they increase their infrastructure? They can increase their infrastructure by using some kind of clouds, maybe Azure, maybe AWS, and they gives us a feature to increase your size of the environment in just fractions of second. Okay, so that kind of infrastructure I'm talking about. And one more example here could be uh, Amazon is having one sale on India's Republic Day. They are having a sale. You can consider any other example, maybe a Black Friday sale or maybe a Thanksgiving sale. The during that time, during those 3 or 4 days, their traffic is more than usual. That time they need high processors, they need high bandwidth, and everything they need more. So what they have to do is they have to scale up. Another example could be, let's take something other than these selling thing. Uh, let's talk about for telecom. Okay, now usually in telecom, usually in a particular city, the subscribers are uniformly divided. Like there can be some areas which are highly crowded, but there can be some area which is less crowded, but still they are uniform, but much difference is not there. But just consider one cricket match or one football match in a city. Okay, if you're if one of the best team are playing, let's say it's an India Pakistan match in India, in Delhi. So what will happen that time? Thousands of people, not even thousands, like more than 50,000 people will gather together in one area. Okay, so will they require same infrastructure, or will their resource requirement will be same? No, they will have a very shoot up requirement. They will be requiring uh, systems which can which can serve those 50,000 customers. Okay, so for that they need something, an infrastructure which can quickly shoot up. Once that requirement is done, they can lose them up. So these Azure, these AWS, these are providing clouds in such a way that you can just increase your bandwidth for a couple of days, pay them on for those days only, and then reduce back to the normal one. Okay, so these are some of the DevOps habits. Any questions now? I know it's more of theoretical, but yeah, I cannot help here. So any questions here? Okay, these were the things I had for DevOps. Now I'll quickly cover up Jenkins, and that will be the last topic for me. So if uh, those people who have already done Jenkins, if they want to drop off, they can. Okay, anything else you want me to cover, do let me know. I can arrange another class. Okay, if you have any questions right now. Okay, Poonam, you have question that we should Selenium grid. Okay, have you covered normal Selenium, all the things in Selenium? Okay, then let's do one thing. I'll cover Selenium grid now, and then we can cover Jenkins also. Okay, so on QA I've written an article for Selenium grid. Okay, So what is this Selenium grid and why it is used? Okay, and after this I'll cover Jenkins. So what is Selenium grid? Selenium grid is another component of Selenium suite which is used for parallel execution of test cases on different machines. Execution is possible on different machines with different browsers or same browsers but different versions at the same time. Okay, so what we do in this is, so why it is being used. One of the example I can give, let's say you're developing Selenium test cases and some thousand test cases comes, like, and there is the test cases piled up to thousand test cases. Okay, now if you have those thousand test cases, then it's very difficult, or you can say it will they will take a lot of time to execute all thousand test cases. What you can do in that case is, okay, we learned in DestinG that you can do parallel testing, and in parallel testing you can execute those thousand test cases parallelly, but that needs a very high infrastructure or one big machine. Okay, so to reduce that complexity or to reduce the requirement of that high-end machine, what you can do is, instead of one machine, you can have multiple machines, uh, add them in a network, like combine them in one single network. One machine can act like a node and other can act like a hub. So here, sorry, one can act like a hub and others can act like a node. Hub will be your controlling unit and nodes will be multiple units. Okay, so node 1, node 2, node 3, node 4, they all are connected in one network. And through this hub, you can control the execution on node 1, you can control the execution on node 2, node 3, node 4, and so on. So this is the benefit of having uh, hub node, this in kind of infrastructure. Okay, so uh, for this, what we need is, so let's first create this network. Let's first learn how to create this network. So to create this network, first step will be that you have to launch your hub. Okay, so for that, the Selenium jar file which you have downloaded, go to that path. So I am here in the libs. Just open the command prompt here. Okay, and to start your machine as a hub, what you have to do is write java-jar and then name of the jar file. So the name of the jar file will be Selenium server standalone. This is the latest version I'm using. Okay, java-jar, name of the jar file, and then what you're creating here, you're creating a hub. So give -role as hub, and then also mention what port you want. So you can give any port. Let's say 4455 is the port I'm giving. If you will not give any port, then it will be running on the default port, and default port is 4 times 4. Okay, 4444. Okay. So this is a single command. What will do, this will make this particular machine as a hub. So here you can see when I opened it, it is making it a hub. And here you can see it is also saying nodes should register to this http colon 192. So I'll just copy this and will keep it with me. Okay. One more thing, to verify whether your hub is running actually running or not, go to your browser and type localhost colon 4455. This was the port number we used, right? So open this. If you're getting this page, that means your Selenium hub is working fine. Here there is a console. Click on that console and click on this view config. Okay, you will see what is the configurations of this hub. Okay, and if any other parameter you want to part, like here I wanted to passport, so I said this 4455. If you want any other parameter, you can just use these variables. Okay, browser timeout, debug, help, just put a hyphen, name of the variable, and then its value. Okay, so this is how you can launch the hub. Any questions here? Okay, so this is first step. Next step is you need to register nodes to this hub. Now, as I don't have multiple machines with me, so I'll consider my the same machine as node, and we will register. Okay, so again I'll search for command prompt here, and we'll say Java -jar, and then uh, name of the jar file. So it will be Selenium standalone jar file, same version. Okay, and then role will be node. So you can say -role, then this will be a node, and then you need to tell where you are going to register. So -hub, and then give the hub. And again, if you want to give the port, so give port, let's say 5566. Press enter. Okay, and you can see registering the node to the hub. So the node is registered to the hub and ready to use. So your node is registered successfully. Okay, and if you come here, you will can see registered a node. So 5566 port number, a node is registered. And if we'll come to this console and do a refresh, you can see one of the node is registered. Okay, but these are the default values. Like it supports 5 versions of Mozilla Firefox, 1 version of IE, and 5 versions of Chrome. This was default configuration. Okay, other configurations you can see here. Okay, if any one of this you want to change, you can simply pass the value, and okay, these are hub. For node, these are the configuration. Okay, so any questions here? So here you can see we have given the port as this, role was node. Any other parameter you want to change, just give hyphen name of that variable and its value.
So we are creating different nodes within one computer system.
Yeah, actually I don't have multiple machines. Even though if I had multiple machine, then also I cannot show you because I'll not be able to share screen of all. Right. So what I did is on the same machine I created a hub. Okay, and then to that hub I registered one more node. Okay, now we two are not in same network. Otherwise, from your machine I could have asked you to register to my node. Okay, so your hub can be created on one machine. That same machine can be used as node, like I am doing, and other nodes you can register from other machines. If let's say I have another system, then I can register through that on this. So you will start seeing all those registered nodes here one by one.
Got it.
Okay. Any other question? And Poonam, I answered your question as well, right? This is what you were asking. Okay, fine. So we have created this setup. Which setup I'm talking about? Let me show. Yeah, this setup. I created a hub. I created a node. If you have other nodes, just do the same thing. Only change the port and register all of them to the hub. So all of them will get registered here to this hub. Okay. Now the next step will be we have configured the host, everything is done. Next step will be we will write the code to execute. Okay, so for that I'll come back here and I'll create one project. let's say I'm creating this Selenium grid, and I'll say main. Okay, I need to import the jar file as well. So right click, build path, configure build path, add external jar, Selenium standalone 3.8.1. Okay, so this jar file is also added. Now I can quickly write the code. Okay, so what you have to do is, uh, before you actually start the writing all other code, here first step will be you need to set the desired capabilities. Desired capabilities is the some extra information which you pass about your browser and its settings. Okay, so there are two ways to set this desired capabilities. One is this desired capabilities. Okay, let's say I name it cap equal to new desired capabilities, and then this caps you can say set capability, then give the name of the capability and its value. This is one way. Or second way can be, here you can simply say desired capabilities dot whatever you want. Say for example you want Chrome browser, so I can simply say dot Chrome. I want a Chrome browser. This is one of the capability. Okay, next is you need, like, here we will not be running directly on my browser, but we will be running on remote WebDriver. Okay, so let me quickly copy it and then I'll explain you all these steps. And I need to look at the IP. Okay, so the IP is also different. Okay, so next step is I'm creating an instance of URL. URL you have to take from java.net. Okay, so this is not a string URL, rather it's not a string URL, it is another class which we are taking from java.net. Okay, guys, just give me a second. There is one call. Just give me a second. Okay, so this URL is a class, and why I'm not taking a string variable, because this remote WebDriver, it accepts the instance of URL which is from java.net. Okay, and uh, what is like whatever string value you will pass, if that will not be in a form of URL, it will throw you an exception. Okay, so I just created an instance of URL which is from java.net. Okay, created an instance of WebDriver. Okay, and I'll refactor it. Right click, refactor, rename, and we'll make it driver. Okay, and here uh, we are using remote web driver. I'm not using Chrome driver or Firefox driver. Reason being, if you'll directly use Chrome driver or Firefox driver, it will run it on the same machine itself. It will not run it on your node. So what is the way? The way is always use remote web driver. Okay, and then to tell what kind of browser you want, you need to set the desired capabilities. Okay, and here it will uh, add throw declaration. So this you have to do because it expects one exception. Okay, and before I do this, I need to set the system property as well. So let me copy paste that path part from somewhere. It is common driver. Okay, and we are good to start. Now I can simply execute the code. So it will be shift alt X and then J. And you can see, okay, this is here you can see the execution capabilities are browser name is Chrome, this capability Chrome, and so on. So it will start execution, and you can see it is being done on the node. Okay, so it will take some time for the first time to execute. Okay, some exception has occurred. Let me see what is that exception. I guess something is changed in this. I guess in the latest version some way of execution has changed. Just give me a second. I've not done it from long, so probably something is changed. Okay, there was one more thing I can try. Just give me a second. I'll go do one thing. I'll copy this Chrome driver exe in directly libs folder. See if it works. Something has changed here in the latest version, so probably I need to look into it. Not sure what exactly is the reason. Okay, some way of invocation has changed. Earlier it was like this only. I remember a -d webdriver.chrome.driver, and then you need to give the path of the Chrome driver exe. Then it used to launch it in Chrome driver format. Okay, so probably I'll search what is the reason why it is not working, and will share. Okay, and I'll send you some what will be the exact way. But otherwise, what will happen when you'll run it through this? It will execute on the code. Okay, so yeah, so this can be done. Okay,
One thing, Saurabh.
yeah.